हेलो, लास्ट में क्या किया था आपने? लास्ट प्रैक्टिकल क्या किया था आपने? हेलो, गेटिंग माय वॉइस?
तो एक्सपेरिमेंट 2 किया था हमने।
व्हाट इज इट? कैरेक्टरिस्टिक ऑफ पीएन जंक्शन डायोड या रेक्टिफायर? हेलो, अरे बोलो भाई, आवाज हु इज सीआर? सीआर कौन है आपका? हेलो, आवाज आ रही है आपको?
यस सर।
सर।
हाँ, तो आपने कौन सा एक्सपेरिमेंट किया है ये तो बता दीजिए। सेकंड एक्सपेरिमेंट किया, लेकिन कौन कौन सा किया नाम तो बता दीजिए। सीआर कौन है आपका? हेलो,
हर्ष। सानिया रहमान।
ओके, तो वो है अभी मीटिंग में है। हेलो, ठीक ठीक, मतलब हाफ हाफ एंड फुल आइडर हो चुका है आपका। ठीक है, तो फ्लो तो आपको पता है कि सबसे पहले क्या करते हैं हम लोग? वी लैब में जाते हैं, वर्चुअल लैब। ठीक है, तो ब्राउजर में जाने के बाद जस्ट यहाँ पे हम जाएंगे सबसे पहले वी लैब्स। ठीक है, ये वर्चुअल लैब है। Here we are going electronics and communication labs. ठीक है, इसमें we have to go into digital electronics circuit lab, IIT Kharagpur, hybrid, just a minute, IIT electronics में। हाँ, गुवाहाटी डिजिटल लॉजिक डिजाइन है। गुवाहाटी या रुड़की? डिजिटल लॉजिक डिजाइन लैब, डिजिटल इलेक्ट्रॉनिक्स लैब, एनालॉग इलेक्ट्रॉनिक्स, डिजिटल इलेक्ट्रॉनिक्स लैब 1 न्यू। ये आईआईटी बॉम्बे है। अच्छा, आईआईटी रुड़की नीचे लिखा है। ठीक है, नाउ यू आर हियर। अब यहाँ पे हम लोग जाते हैं लिस्ट ऑफ एक्सपेरिमेंट। ठीक है, ठीक है, लिस्ट ऑफ एक्सपेरिमेंट में यहाँ पे ये पहला एक्सपेरिमेंट आपने कर लिया। ये लिस्ट आपको दिख रही है? इज इट विजिबल टू यू?
यस सर।
यस सर।
तो इसमें जो है पहला एक्सपेरिमेंट, दूसरा, इस लिस्ट के अकॉर्डिंग आपने पहला दूसरा कर लिया या तीसरा कर लिया? मेरे तीसरा नहीं किया मतलब।
यस सर।
तो थर्ड इज हाफ एंड फुल सबट्रैक्टर। फुल सबट्रैक्टर का मतलब क्या हुआ? दैट मीन्स 2 बिट्स को सब्ट्रैक्ट करने के लिए जो सर्किट यूज किया जाता है, दैट इज कॉल्ड सबट्रैक्टर। हाफ का मतलब क्या हुआ? 2 बिट को सब्ट्रैक्ट करेगा, बट जो इसमें तीसरा जो हमारा कैरी होता है या बोरो होता है, दैट देयर इज नो प्रोविजन टू हैंडल दैट वन। तो इनपुट इसमें सिर्फ 2 ही होता है, और आउटपुट क्या होगा? एक डिफरेंस होगा और एक बोरो होगा। तो इसका क्या क्या होता है? लॉजिक टेबल क्या क्या हो सकता है? इनपुट क्या क्या हो सकता है? 1 0 0 0 होगा, 1 0 हो सकता है, 0 1 हो सकता है, या 1 1 हो सकता है। दैट्स इट, ये सबको पता है इसका। तो इसके आप हेलो,
यस सर।
Everyone is getting my voice and my language, because there any foreigner student in your class? Because I am sometimes using uh, local language.
Yes, sir. I am furniture.
Okay, okay. So, pardon, I don't know that you are foreigner. So now I am repeating that thing once again. So here we are using V labs for performing our experiments. V lab is a site created by Government of India for performing different experiments in online mode, and that is our that is why we are using that VLAB, because we don't have permission to take it offline. So
Excuse
here,
me, sir.
first of all,
हेलो
hello.
सर, कुछ
uh,
स्टूडेंट ज्वाइन नहीं हो पा रहे हैं, आप एक्सेप्ट कर लेते वो एडमिट. हेलो.
just a minute, just a minute.
ओके सर.
ठीक है, और कोई भी है? अब बीच में नो डिस्टर्बेंस प्लीज, नॉट अलाउड.
ओके सर.
ठीक है, अदरवाइज इट इज फिर कोई नाउ आई कैन आई स्टार्ट नाउ? और कोई भी है ज्वाइन करने के लिए तो बोल दीजिए, देन वी विल स्टार्ट. स्टार्ट करें? सीआर प्लीज टेल मी, कैन आई प्रोसीड और वेट? बताइए, वे जल्दी बताइए, स्टार्ट करें अब, फिर वापस अब नहीं आएंगे हम. तो ये वो दो तीन, आई एम गिविंग 3 more minutes. आफ्टर दैट आई विल स्टार्ट माय सेशन. ओके. Okay, let's start. So we are starting our lab on virtual labs. VLab is a site uh, designed to perform experiments online, so that what we are performing in our labs, we can anyway that can be performed on some software, and that is provided by Government of India, and that is taken care by IIT Delhi, and different ITs are combined together to design this platform. So we are also using that platform for performing our experiment, because we have no permission for coming offline for having that lab in our university. So please, that must be performed by you individually at your end, and what you are doing on software, that same thing you can do in your lab also. So perform that experiment in that way that you are doing that thing in your labs. So connect circuits properly, check the circuit properly, and then check its output. And whenever we have offline classes, you must come, and you are welcome to perform your experiment in our labs, where you can do all these things physically. So you have ICs in our lab, we have breadboard in our labs, we have power supplies, we have all those infrastructure which are needed uh, for your experiment. Okay. So okay. So I hope that when you come into college, you must perform it physically also. So uh, so learn this lab in that accordance. Okay. Now just a minute. Somebody's. So we are here in virtual lab, and we have to perform half and full subtractor. Subtractor means subtractors have when we are having subtraction, what we get? We get two things. One is called difference, another one is called borrow. So whenever we design a subtractor, we must handle these two things. One is called difference and another one is called borrow. So whenever we are comparing the two things uh, by having that scheme, we can say whether this number is having this much larger with this number, and that is called subtraction. This is one way of comparing two signal two inputs. And in digital, we know there are only binary value that can be taken as our input. And in binary also we have whole binary numbers. That means binary. What is binary? Binary which have base 0 and 1, that is called binary. And binary number systems contains all those qualities which we have in decimal number. So fractional value are also in binary numbers, that is 1.01 is also available in binary, but we don't use that 1.01 in our digital circuit as input. So input must be a whole number when we are talking about digital input. So if we are talking about two inputs, that must be whole number, and that can be either 00, 01, 10, 11. So it can't be that one input is
Sir, screen is not visible.
now is it visible.
Yes.
ठीक है. Okay, getting my voice properly.
Yes. Yes, sir.
So what should be the output? So you must take care of that. If somebody asks why we are not taking 1 and 0.1 as the input of our digital system, what should be your answer? That digital is not taking only binary values, but with a binary value which is also a whole number that can be taken as input. So what are the possibilities? If we are taking that constant on digital inputs, then the values are 00, 01, 10, 11. Now we have to design a circuit which can subtract 0 to 0, 0 to 1, 1 to 0, and 1 1. So if we are subtracting 0 minus 0, what we get? Difference is what? Can anyone tell me? Difference बता सकते हैं? Unmute yourself, any of you, and tell me what is the difference? 0 and 0. Difference is? Tell me. It is not a very tough task. Anyone can say what is the difference between 0 and 0?
0, sir.
0, of course. Why you are wasting so much time in telling what is the difference between 0 and 0? Nothing, no difference at all. What is the difference between 1 and 1? No difference. So difference is 0. So
Yes,
if
sir.
nothing is there, so we can say that there is no difference. So difference is zero. I am talking about only difference now. If we have one input as zero, another input as one, what is the difference between this one? Now, can anyone tell me?
One,
Zero
sir.
and one?
One, sir.
One. Very good. Absolutely right. And if there is input one zeros, then what is your difference?
One, sir.
One,
One.
sir.
Again, one. Difference is in between zero or one
One.
zero difference. One. And when
Yes.
input is one, what is difference?
Zero, sir.
Zero. So now,
Yes,
Zero.
sir.
we have input output truth table. That is, input is 0, 0, output is 0. Input is 0, 1, output is 1. Input is 1, 0, output is 1. Input is 1, 1, output is 0. Now, can any basic gate can have this characteristics? So it
Uh,
has a, huh? Yes.
yes, sir. Uh,
Which gate? Which gate
mm,
can perform that task?
uh,
Yes, yes, come up. 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0.
सर और गेट
sir, or gate.
No, 1, 1, 0 है. 1, 1, 1 not. 1, 1, 0
Sir,
है.
and gate.
AND gate भी नहीं है because in AND gate 0, 0, 0,
XOR
0,
gate.
1, 0.
सर एक्सोर सर एक्सोर
XOR.
एक्सोर
Very
है
good.
सर
Absolutely correct.
एक्सोर
It is
एक्सोर
XOR gate. So now you have your answer. So if you are having half subtractor, you can have a XOR gate, and if you are providing two inputs to it, the output is telling you what is the difference between these two inputs. So that's one part. Another part is that, okay, if we have to get actual difference, we must have one more thing that is called borrow. So if, because the difference between 0 1 is 1 and 1 0 is also 1, but in difference between 0 1 we have a borrow. 0 minus 1 equals to minus 1 and 1 minus 0 equals to plus 1. So both are not same thing. One is having a borrow and another one is have no borrow. So if I am writing a output for borrow, what is our output? What is borrow between 0 and 0?
Zero, sir.
Tell me. 0. And what is the borrow between 0 and 1? 0 minus 1. What is borrow?
One.
1. Very good. And 1 and 0? Borrow is
Zero.
0. Very good. And 1 minus 1? What is borrow?
Zero, sir.
0. Absolutely right. So now can you tell me, can we have a gate which can perform 0, 0, 0, 0, 1, 1, 1, 0, 0, and 1, 1, 0? Can you tell me any gate can perform that thing task? Your answer must be no, because we don't have any basic gates which can have these characteristics. I hope so. Are you agree with me?
Yes, sir.
Then what we have to do? We have to use combination of gates. So here we need some combination, and since only one output is 1, so we can have to look into the inputs are 0 and 1. So first input is A, another one is B is 1, A is 0, and output is Y, and Y is only 1 at this input. So we can write Y equals to A bar B. A bar B means we have to use a NOT gate at A, and we have to use and a AND gate whose inputs are A bar and B. Getting me?
Yes, sir.
So now we are able to see the circuit. So So we have theory also here. So you can see that theory what we have seen. So this is the truth table. Is it visible to you?
Yes, sir.
Now what you have said that can be combined together. So here you have difference. Getting me what you are saying? So you have designed that circuit by your own, and what you have get at borrow, you have your own circuit in that not get a bar, and here you get b. So it will be borrow equals to how much? A bar b. ठीक है? Is it correct? ठीक है? So now we have full subtractor. In full subtracted we have three inputs, and in three inputs we are taking that same thing, that difference and borrow, and after that we can say we can simplify this equation, and we will find that this difference will be k. You can solve that one by using kmax, or you can just write what are the expression at which we get 1, and we can use uh, sum of product or product of sum for finding out the output, and you will find when you are simplify that you will get d equals to a xor b xor b in. So b out borrow out is equals to a bar b in plus a bar b plus b dot p in, and this is the circuit. Okay, so both that can be. Now we are going to having. So here after that we have pre-test. So we are skipping that. You can evaluate yourself here pre-test. So here we have procedure. You can write this procedure on your copy, and in lab when you are come you have to follow these procedure. Now here simulation is there. So in simulation we have circuit that can be verified of subtractor. Okay, so here we have a IC which is 7486 that is for uh, XOR gate. Is these gates are in the form of ICs, and it is quad IC which contains 4 XOR gate. Similarly, we have 7404 is used for not gate. Not gate IC is 7404, and we also requires AND gate. That is that IC is number 7408. So these numbers are important whenever you are performing some experiment. You have to take your IC according to this number, and when you have this IC, you just take this IC, and that IC can be have a cut mark there. You can see here one cut mark is there. From where you have cut mark at right, you will start pin number 1 2 3 4. Is it visible to you?
Yes, sir.
Yes, sir.
Pin number 7, and then we have 8 9 10 11 12 13 14. So pin number 1 2 is the input of one AND gate, and 3 is the output of that AND gate. Similarly, we have 4 5 as the input of second or AND gate, 6 is its output, 7 is used for ground, and here 9 10 is the input of another or AND gate, and we have at 8 we have output. Similarly, we have another AND gate and its input. So if we have IC, we can put it into breadboard, and we can connect our inputs according to our circuit. And here we have VCC. In most of the that digital ICs, 7 4 series ICs, we have at 7 we have to ground our ICs, and at 14 we have to provide 5 volt, that is called VCC. 5 volt supply is given. So you can see here in all the 7 per ground, and now it is 14 per VCC. Similarly, 7 grounded, 14 VCC. So in all that, and that is plus 5 volt. Okay. Now what we have two circuit, two outputs are there. Uh, one is for difference and another circuit is for borrow. So for difference, what should be our circuit? One XOR gate. So here one XOR gate is taken. So this 1A, 1B is the input of that XOR gate and 1Y is the output. So whenever you provide 1 2 as input, you will get difference at 3. So we have here circuit, here difference, borrow. Okay. So whenever you put your values there, you can add these values in your table. Okay. So we will see that. And after that, we have another thing that is called borrow circuit. And borrow circuit, we have A bar. So here we are taking A here and A bar can be get from here. So A bar is going to the AND gate. Here A bar is there and B is coming from this input B. Okay. So first of all, this is the switch. You can on this switch, you can off this switch. Okay. Now supply is on. You have instructions also. You can see there's an instruction here given. The switch on state is green. Okay. So we are just supplying all this one. After that, we have 0 0. Input is 0. So we can, what should be the output? Difference is 0 and borrow is also 0. So we are adding. So you can get serial number 1. Input is 0 0. Difference is 0. Borrow is 1. Now we are making B as 1. So we are putting that 1. Now what should be the output? 0 1. So यहाँ पे difference is 1. Borrow is also 1. We are adding this to table 1. So 0 1. Difference 1. Borrow 1. Now we are taking this one as 0 and this one as 1. And now what should be the output? Can anyone tell me? Difference क्या होगा? Borrow क्या होगा? Please tell me.
So difference 1 होगा, borrow 0 होगा.
Very good. So you can get difference 1 0. Now what should be the next combination? Both should be 1 1. So 1 1 में what should be difference and what should be borrow? Next another student.
Both 0. So both 0.
0. So we can add it and both are 0. In similar way, you can perform your full wave, full subtractor, and you can you have also make this circuit on your copy, and you can write this truth table. Okay. So please do it on your copy. Next day we will discuss next experiment. Okay. And you can also perform this experiment at your own. Now you have understanding about this. So whatever the circuit is, whatever the experiment list is there, you can perform rest of the experiment. Just looking for another class. ठीक है. So we have just a minute. This is our list of experiment. Now we have next one is realization of logic function with the help of universal gate. So by using NAND and NOR gate, we can perform any operation that can. These are called universal gate. Why it is called universal gate? Because you can design any digital circuits by using only this one of them. So that is next experiment. Construction of a NOR gate, latch and verification of its operation. After that we have flip flop. So we can have, इसमें just I am seeing what we have. So here you can go to the theory, and in theory we have, so here we have different, that means in universal gates we can have, by using NOR gate we can make OR gate, by using NOR gate we can make and by using NOR gate we can make NAND gate, by using NOR gate we can make NOT gate. So all these gates are possible with the help of NOR gate. Similarly, all these gates are also possible with the help of NAND gate. I hope that you have studied that thing in your theory. Have
Yes,
you
sir.
studied that thing in your theory?
Yes, sir.
So now just I am skipping its rest of the thing. You have procedure here, simulation. So in simulation, you can get your circuit, and here instruction NAND to NAND and NOR. So first of all, what we have, NAND as universal gate. Instruction is there. So here NAND and NOR is there. So using some, first of all, we are just trying to perform by using NAND gate. So you have to select NAND gate. NAND as NAND as NAND as and now you can see how you can connect this thing NAND to and NAND to, and we have to make connections. This is our NAND to AND. So how can we can make connection? Can anyone tell me? This is AB. This is our first NAND gate. Since two NAND gates are required, so that we get A dot B. What should be the, what we can do? बताइए. We can just simply having, we can connect this one. We can make this one with this one. Here both are combined together. Here in mobile it is difficulty. You can combine these two inputs. Okay, you can do it at your system. Okay, just you can make connection with. So we have options. So we can reset our circuit. Okay. Here you have to make your, we can make this one, and after that we can having this one, we can connect this one. Okay, that is the connection. We can check the connection. This is wrong because this can be, because it has certain pattern. If you have to follow that connection is correct, but I think if this is the case. Right connection. So both connections are same connection, but this is designed for the it, so that it's showing wrong. So now connection is right, and now you can check. Check. We have check connection. Now we can have next. So similarly, you have next gate and can make connections, and you can check all these gates. Okay, this is XOR. Okay, you make your diagram on your copy, and after that you just perform all this experiment. So it will take some time. So first of all, you can make this experiment into two groups. One is uh, universal gate verification, universal gate no NAND verification. Another one, next experiment you can write aim as universal gate NOR verification, because all these two gates are having four circuits. So you can do that thing. Okay. Okay. So now you can perform your task, and you must also note down its on your experimental file. Okay. Okay. Now, if you have any doubt, any query, you can ask now. And it is better for you, so that you can perform these things uh, by yourself. किसी को कुछ पूछना है? Anyone have any doubt? No?
No, sir.
Okay, so kindly send attendance, and we are disconnecting. Who is CR?
Yes, sir.
So please send me attendance. Just
Okay, sir.
take a snapshot of students list, and send it on my WhatsApp number.
Okay, sir.
सेंड कर दिया? चलिए ठीक है, तो अब now you perform it. It is better to perform the experiment by using laptop or desktop.